All right, guys, welcome back to our Target 3 notes. So remember where we left off last time was kind of summarizing this process of finding zeros by first replacing f of x with 0, replacing the range, the y, whatever variable is being used for the range here with 0, because that's what it really means to find a function, guys, is finding an x coordinate, which makes f of x, y equal to 0. And then using our tag team of factoring and the zero product property to get the value alone. So what we're going to do in these notes, guys, is we're gonna walk through some more problems. We'll do some problems where we do have to use the AC method and grouping just to hopefully give you a refresher here. All right, so when we come across a problem like this, the first thing we're going to see is these directions. Find the zeros. As soon as we see those words, guys, as soon as we see those words, find the zeros immediately. If it's not already done for you, replace the range variable with 0. Replace f of x or y with 0, because the only way that we can find zeros, find the x variables that are zeros, is if the range is actually the number 0. All right, once we've done this, we now need to look at this equation and ask ourselves, do we have an equation that we can use the zero product property on? Well, if we look at this, for the zero product property, we need 0 to be on one side of the equation. We've got that, and we need the other side to be fully factored. We do not have that. X squared minus 18x plus 65 is not factored. So the first thing we have to do is factor it. Now, the nice thing is the leading coefficient, the a value, is 1. So we can use our shortcut to factor this quadratic here. So 65 is the c value, right? A, b, and c, right? Negative 18 is b. So we need to come up with two numbers that can multiply to 65 and add to negative 18. If you want to think about it yourself, go ahead and pause the video so you can think about it and see if you can come up with these numbers. Go ahead and pause. All right. So hopefully you came up with the numbers negative 5 and negative 13. Because negative 5 times negative 13 is 65, and negative 5 minus 13 is negative 18. Now that we found those numbers, we know that the first term in each of our factors binomial factors has to be x, and the second terms will be these two numbers themselves. Once we finish this, guys, factoring has done its job. That's factoring's half of this wrestling match, this tag team match, and factoring now is going to reach outside the ring, tag its partner. And if you've never watched WWF or WW, now it's WWE wrestling, I apologize for the tag team analogies. Just ignore the tag team analogies. But if you have watched them, this kind of makes sense. Factoring starts in the ring. It does some work on the equation, throws it around a little bit. Then it's going to tag its partner, zero product property, to come in and finish the equation off and get us our zeros. So now with zero product property, we have an equation that is written in a way that we can apply the zero product property. I have a fully factored expression equal to 0. If I have those two things in place, the zero product property can be used. All right, so what we have here is two factors, each have a variable, which means each of them could possibly give us a solution to this equation. So in one world line, going back to our Avengers time traveling thing, right? We split off, and x minus 5 is the factor that is equal to 0, and we solve and get x equals 5. In a second world line, a different world line, we have x minus 13 is equal to 0. That's the factor that is equal to 0 and gives us the solution. So we have x equals 13, right? And what that tells me, guys, is that my zeros, right, are 5 and 13. And that's what we're looking for. Again, these are the zeros going back to the original equation here. You don't get lost in all of this work, guys. What we're doing here in finding these zeros is exactly the same thing that we were doing here when we were looking at the graphs, and here when we were looking at the tables. Just instead of looking at the graph of a quadratic function or a table of ordered pairs of solutions of a quadratic function, now we're looking at an equation of a quadratic function and doing this. All right, let's dig in and let's start looking at some that are not as easy as that shortcut. Let's look at number 2 here, right? So again, if we go to our directions, we see in the directions, what are the first three words? Find the zeros. So that gives us the permission, the ability to automatically replace the range value with 0. All right, now, unfortunately for us, and we do have to factor here. This is not factored, so we need factoring in our tag team. But notice, guys, A is not 1. All right, when A is not 1, we have to do a little more work. We've got to use the AC method to turn 3 terms into 4 terms and then factor by grouping. So let's start off with the AC method. The AC method tells us to do 2 times 5, which gives us 10, right? Actually, I'm going to move this over here to this side so I can just work down. All right. And then what we're looking for are 2 numbers that will multiply to 10 and add to 7. All right. So, hey, guess what numbers they are? 2 times 5 is 10, and 2 plus 5 is 7. So then what we're going to come over here and do, the AC method is going to say split the 7x into 2x and 5x. And now we have a 4-term quadratic, and we can factor by grouping. So if I take the first group here, I'm going to stay in green here for my factoring. I can pull out a 2x from each of these terms. That's the greatest common factor. And guys, just remember, 2x divided by 2x is not 0. It doesn't go away. It's 1. It's 1. So make sure we pay attention to that. Here, my greatest common factor is going to be 5. That will leave me with x plus 1. Right now, my greatest common factor is x plus 1. So if I divide and pull an x plus 1 out of each of these here, I'm going to have x plus 1. And what I'll have left over is 2x plus 5. Again, I skipped a lot of steps, guys, in the grouping method here. If you are confused about the grouping method, all right, if you're confused about grouping and need a refresher, remember the grouping method of factoring was Unit 6. Target 2B. Go back to those notes. Look through those notes. Look through the worksheets, answer keys, and everything like that on grouping. Also, I did do an example in the study guide for the Unit 6 test on grouping, so you can go back and watch that as well. All right, so factoring is done. It tags 0 product property. Now I can take each factor and in their own individual world lines where they are the solution, find... Oops, nope, not positive 1. Find the values which would make the equation true and would be the zeros of the quadratic function. Boom, there we go. All right, so in this problem, factoring was a bulk of the work. 0 product property, while essential, really was pretty easy here at the end. Let's take a look at some other examples. Let's definitely take a look at number 3. So again, what's the first thing we do? The first thing we do is we replace f of x with 0. Now, this problem looks a little funny. I want you to take a second and think, why does this equation look a little different, look a little bit funny? All right, hopefully you realized the reason this looks a little odd, nope, I want to move both of them, is because, guys, there is no c value, or the way to think about it, the c value is 0. When our c value equals 0, I'll give you a hint. Don't try and use the AC method. Use greatest common factor. Right? If you try and use the AC method or the shortcut here, it's going to be really complicated because there are an infinite number of factor pairs for 0. It's unlimited. So it makes it kind of hard to work with. But notice, because we don't have a 0 anymore here, because we don't have a c value, I now have a greatest common factor between x squared and 16x, which I didn't have before, right, in this quadratic because the c value didn't have an x. So what we can actually do in this case is just factor out my greatest common factor. Well, the greatest common factor is just x, right? So I'm just going to divide by x. And if you want to, you can divide 0 by x. It's just going to be 0. And what that's going to give me is x plus 16 is equal to 0, right? This kind of just takes care of itself because it's 0 there. So we took x squared plus 16x and wrote it as x times x plus 16. Well, this is now ready for zero product property. Just because they're not both binomial factors, guys, doesn't mean we can't use the zero product property to find the zeros. Remember, if we go all the way back to the first page, the very first example we worked with here in using the zero product property to solve this equation had a monomial factor of x and a binomial factor of 2x plus 5. We're just going to do the same thing here. So I pull this out, and in the world line, first world line, x is the factor that's equal to 0. In our second world line, x plus 16 is equal to 0. We solve here, we get negative 16. So this tells me my zeros are 0 and negative 16. All right, those are the values that if I plug them back into the function would make f of x equal to 0. Really quickly looking at 5, I'm not going to go super detailed into 5, but after we replace f of x with 0 here, guys, what factoring needs to be done? Well, hopefully you've looked at it and said none, right? This is a problem that does not require factoring, right? It's already factored, And I'll tell you, the biggest temptation in a problem like this, guys, is to distribute. But remember, if we want a factored form, if we want Optimus Prime to be a robot, don't turn him into a truck. All right. If he's already a robot and we want him to be a robot, just leave it be. Right. This is already factored. So we can go straight to, the zero product property in this example here. And again, I'll finish this in the notes. You can see the answer key. But I want to look quickly at number 4 here. So again, I'm going to beat this first step to death, guys, because it is really important that we always remember that the range value, f of x or y, is 0 here. All right, so now this looks a little funny too. 4 looks a little funny when we compare, and it's not because the c value is 0, but we can see as we look at 1 and 2 and compare it to 4, we can see the issue here is that the b value, the middle term, is 0. Right? Plus 0x. Well, we just do this the same as we always did, guys. Factoring, our leading coefficient a value is 1. So I need two numbers that will multiply to negative 81 and add to the b value, 0. Well, that's really easy because to add to 0, you have to be opposites. So we have negative 9 times positive 9 gives me negative 81. And negative 9 plus 9 gives me 0. So x minus 9, x plus 9, and now we're ready to finish this with our zero product property and solve. All right, sometimes, guys, you really will very rarely see the range not written by itself, but it's possible. All right, so just really quickly, look at 6. When I plug in 0 for f of x here, all right, this is one more unique situation. All right, well, x squared plus 0 is just x squared, right? Now, what's the issue now with using zero product property? Well, not only do we not have a factored expression, we don't have anything equal to 0. When we are trying to use the zero product property, guys, not only do we have to make sure we factor it, but we've got to make sure something is equal to 0. So how can we take this equation and write it so that one side of the equation is 0? Well, pretty easy. We just need to cancel out completely one side. I would always recommend, guys, if you need to cancel so x squared stays positive. All right, that is a little, it doesn't, let me make it very clear. You don't have to do that. I am saying this makes your life, the problem in your life a little bit easier. So in this situation, I'm actually going to cancel the 12x by adding it to both sides and canceling the 36 by adding it to both sides, right? So that cancels everything over here, leaving me with 0. And on this side, I have the x squared, a positive 12x, and a positive 36. Now you can see I have a quadratic equal to 0, ready to be factored and find the zeros. 7 is similar, where you're going to have to move some stuff around to get 0 by itself on one side to use the zero product property. All right, so I don't want to take up any more time in the video. Any work I did not finish in the video, I will finish in the notes, so you can check that, try them on your own, and see if you're doing them right. Hopefully, everything we did made sense, that you feel confident to go ahead and try problems on the worksheets and in the formative. about finding our zeros using the tag team of factoring and zero product property. If you don't, please, 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 guys, reach out, ask questions, engage, come to the Zoom chat and ask questions. I'd love to talk with you about all things in life as we have so far. But also, you know, if you actually wanted to talk about math during those Zoom sessions, that would be fine as well. All right, guys. Well, until the next set of notes, I bid you adieu.